Hey everyone, and welcome to this explainer brought to you by Forge College. Today, we're jumping right into a classic engineering headache, making the leap from the Ethereum virtual machine over to the Solana virtual machine. As you'll see sketched out across the minimalist patent-style diagrams we're using today, our focus is squarely on curing your dependency headaches before they even start. We are going to install and configure your Solana and Anchor CLIs the exact right way.
To give you a quick lay of the land, this explainer sits right in the middle of our Preparing for Migration module. We previously covered planning the migration environment, right? Well, today, we're actually installing those tools. We're laying down that rock-solid foundation so that in our next lesson, we can comfortably scaffold out our entire Anchor project.
So you might be wondering, why go through the trouble of writing an automated setup script? Why not just blindly run npm install on a bunch of packages and, hope for the best? Well, if you've been writing code for more than a week, I guarantee you've used the classic, "Hey, it works on my machine" excuse. We all have. But doing manual setups, that is literally the fast track to dependency hell, where your code compiles beautifully but makes your teammates' laptops sound like a jet engine taking off.
Our migration blueprint highlights this core issue perfectly. Manual instructions are error-prone. Different machines end up with slightly different CLI versions. Think about it. When you're transitioning from Hardhat over to Anchor, having inconsistent tool chains across your team is just going to cause spurious failures. You'll end up wasting hours debugging what you think is a code bug, but actually, scratch that, it's really just an environment mismatch.
Okay, let's dive into our engineering schematic for today. First up, the migration blueprint. Next, the reproducible setup. Then, firing up the local validator. Followed by smoke testing the setup. And finally, our final verification steps.
All right, moving right along to Section 1, the Migration Blueprint.
This is where we map out our exact tool equivalents. Take a look at this table we've drawn up here in dark green ink. What's absolutely crucial is how clearly we are defining our baseline requirements. We aren't just vaguely saying, hey, install Solana. No way. We are pinning our versions. We're locking the Solana CLI at 1.16.10, the Anchor CLI at 0.27.0, and specifying the stable release of the Rust compiler. Pinning is a real game changer because it guarantees everyone on your team is building on the exact same foundation.
Now, before we actually start writing code, we need to lock in this super important engineering concept, an idempotent script. That's just a fancy way of saying a script that can be executed multiple times without changing the environment beyond that initial run. Basically, if a highly caffeinated teammate accidentally runs the setup script 10 times in a row, it's not going to duplicate configs or blow up their machine. It just safely ensures the environment is exactly as it should be.
Which brings us perfectly to Section 2, the reproducible setup script.
Let's look at the actual logic that builds this pristine, automated environment step by step. It executes a really systematic flow. Step 1, it checks our prerequisites, our Rust and Node actually installed. Step 2, it pulls down the Solana CLI at our pinned version. Step 3 does the exact same thing for the Anchor CLI. Step 4, it creates a local keypair. And Step 5, it auto-sets your local RPC URL. Boom, zero guesswork involved.
I want to focus on Step 4 for just a second. The script safely generates a durable local keypair located at the path you see there. This gives you an identity to deploy local programs, but listen closely, this is for your sandbox only. We keep this file strictly local so your private material stays far, far away from your public version control. Seriously, keep those out of GitHub.
All right, Section 3, firing up the local validator.
With all those tools installed, it's time to boot up our isolated playground. Back in the Ethereum world, you were probably used to running a local Hardhat node. Well, over here in Solana, we use what's called the Solana-test validator. It provides an in-memory ledger and a JSON RPC endpoint that mimics real cluster behavior entirely locally. It's fantastic because you can deploy and test your programs without ever needing to touch the actual internet.
And do you remember Step 5 from our setup script? Right, it automatically configured our CLI to target this specific local RPC endpoint, localhost port 8899. Because the test validator binds to that port by default, our environment is now completely, seamlessly wired up to talk to our local ledger. And you didn't have to do any extra manual configuration.
Okay, let's move into Section 4, smoke testing the setup.
This is the fun part, proving it actually works. We're going to run a few deterministic smoke tests to guarantee those pinned versions are active. So, pop open your terminal and run Solana --version and Anchor --version. They should spit those exact pinned numbers right back at you. Then, Solana config get verifies your port is active, and Solana-keygen pubkey prints out your local address. If all these match up, your baseline is rock solid.
Finally, we arrive at Section 5, Final Verification Steps.
Let's wrap up our compilation test and make sure the Rust toolchain is properly linked. We do this by creating a minimal Anchor workspace with just 3 simple commands. First, Anchor init hello Anchor -- JavaScript generates a sample program. Next, you just cd into that new directory. And finally, you run Anchor build. This tells the Rust toolchain, hey, go compile this Solana program. If it works, it successfully drops the compiled artifacts right into your target directory.
So what does a passing grade actually look like? Well, your acceptance criteria are met if your CLIs match your pinned versions exactly, your RPC is pointing to localhost 8899, your terminal prints a valid public key, and your build command produces those BPF artifacts without throwing any errors. If you hit all 4 of those marks on this checklist, congratulations, your setup is fully capable and ready for the migration work ahead.
Now, if you do hit a snag, don't panic. Here's a quick troubleshooting checklist. If Anchor is complaining, double-check that your Rust toolchain is actually set to stable. Getting a connection refused error? Ensure another random background app isn't hogging port 8899, and just verify your firewall rules aren't aggressively blocking your local host. Honestly, one of those 3 usually fixes the problem right up.
So, as we wrap up, I want to leave you with a bit of a provocative question. Is your team's development environment truly reproducible now? Think about it. By standardizing this baseline and committing your idempotent setup script to your repo, you're not just fixing your own laptop, you are literally eliminating onboarding friction and debugging nightmares for the entire engineering team. And honestly, that is exactly how professionals migrate ecosystems.
And with that, our environment setup is officially complete. Make sure you keep that setup script handy because next time we'll be using this pristine environment to scaffold an Anchor project. Huge thanks for joining me today. Don't forget to head over to forge.college to learn more about this and to explore a whole bunch of other amazing Web3 resources. See ya in the next explainer.